Welcome to your very first video lesson for algebra regents. All right, so every day when we have a video, you are going to need your note packet, you're going to need a writing utensil, and you will also be needing your calculator. So just as a gentle reminder, this is what a TI-84 calculator does look like. Everybody will need to have one of these at home, so that way you can learn how to use them and use them whenever you are taking your notes at home and doing your homework. All right, so let's go ahead. Now, with a video lesson, the one thing to remember is that at any point in time, you can stop, pause, or rewind the video if you missed anything. So make sure that you're working at your own pace, because I might sometimes go a little bit quicker through the notes. All right, so for this video lesson, we've got two main goals that we're trying to accomplish. Okay, our first goal is to use orders of operation to solve complex arithmetic equations. And the second goal is to review number systems and be able to explain which number system to use in different situations. So let's go ahead and turn to our first worksheet in our notes, and let's try that out. All right, so orders of operation. Many of us remember that by using the key phrase PEMDAS, parentheses, exponents, multiply, divide, add, and subtract. But also with PEMDAS, we also have to remember a few helpful hints. When you multiply two negatives, you get a positive. When you multiply a negative and a positive, you get a negative. And when you hear the words subtract from, you're going to start with the quantity that comes after the word from. All right, so let's jump right into it and let's try a couple of these problems out. So number one, we see here's our first expression. There's no equal sign. This is an expression. The first thing we want to do is get rid of the parentheses. So here I have -4. I'm just going to rewrite -4. Then I have a -10. Remember, when you have a negative and a negative, that becomes a positive. So +10 and then +8. So now we can go ahead and just add across. So -4 plus 10 is 6. 6 plus 8 is 14. So we have our first solution. Now, if I want to double check that with the calculator, the graphing calculators are very nice because you can actually input the parentheses right into it. So I'm going to go ahead and type it in exactly the way it's written. So parentheses, -4 minus parentheses, -10 plus parentheses 8. I hit enter and we get 14, which is exactly what we got at the start. All right, so let's go ahead and double check now with the next one. So number 2, we have multiplication all the way. So when parentheses touch each other, that means you're going to multiply. Now if I wanted to rewrite this a different way, I could go -4 times -10 times -8. So since everything is multiplication, we can multiply right across. So -4 times -10, so these two will give me positive 40, times -8 is going to give us a -320. And we've got our solution. All right, let's go down now to number 3. So here we have -1 raised to the 6th power. Now, whenever you take parentheses and you raise it to a power, we're going to write the parentheses as many times as we see the power. So here, I'm going to write -1 6 times. And 6. Now, all of the parentheses are touching, which means we're going to be multiplying. So if we look carefully, we have a negative times a negative, so these become positive. Negative, negative, these become positive. Negative, negative, these become positive. So now all we have, 1 times 1 times 1 times 1 times 1 times 1 gives me a positive 1. And if I wanted to check that in the calculator, I'm going to go ahead, parentheses, -1. So it has to go in parentheses. And then this little button here is called the caret button. And we push that button, and that means it's being raised to the 6th power. And we hit enter, and we get positive 1. All right, so let's try the next one. Now we have positive 5 as your power. So I'm going to rewrite -1 5 times. Now we have negative, negative, these become positive. Negative, negative, these become positive, but there's still one negative there at the end. So 1 times 1 times 1 times 1 is 1 times -1 is -1. So let's take a look. Here we got a positive, here we got a negative. Let's look at the powers to see. When we got a positive 1, our power was even. That means it's divisible by 2, and whenever you have 2 negatives, it creates that positive. Here, our power was odd. So that means you had pairs of 2's, but one of them was going to be left by itself to give you the negative 1. So let's take a look at number 5. Negative 1 raised to the 101 power. Now, we don't want to have to write this out 101 times, so just look at the power. Here we see that it's odd, which means we're going to get a negative 1. And again, if we wanted to check that in the calculator, negative 1 raised to 101 power, and we get negative 1. All right, now let's go down to number 7. Here it says subtract negative 10 from 2. So here we have the word from. Whenever you see the word from, you're going to start with whatever comes after the word from. Remember, when you give a gift to my students from Miss Koeppel, okay, since it's from me, I'm the one that started with the gift, and you're the ones that ended with the gift. So that's why you start with what comes after the word from. So this becomes a 2 minus negative 10. All right, and that means we have a negative negative, which becomes a positive. So 2 plus 10 ends up being 12. All right, let's take a look at the next one. So once again, we see that word from. So we're going to start with what comes after the word from. So we're going to start with the negative 9. So negative 9 minus 5. Okay, and at this point, the program is going to stop. You're not going to be able to go any further until you put the answer to this in your computer. So go ahead and put the answer into the computer. All right, everybody, if you put in negative 14, you've got it. All right, so that's our first goal for today, to go over order of operations. Now let's go ahead and flip the page over. Our second goal for today is to review our number systems. All right, so let's go ahead and take a look. Our first number system are real numbers. Now, a real number is any number that you've ever learned in your entire life. It's any number that you can put on a number line. Whole numbers, rational numbers, irrational numbers, integers, any number you can think of. So this could be pi, it could be 5, it could be negative 2, it could be 1/3, it could be 6.5. All of those are real numbers. Okay, now subcategories of real numbers, we have our whole numbers. Now, whole numbers are the numbers that you used when you were in elementary school. They're the numbers from 0 all the way up to infinity. Now, there was no negatives in elementary school, okay? And there's also no decimals or fractions, just for the whole numbers. I know you did those in elementary school, but whole numbers, no decimals or fractions. So that would be 0, 1, 2, 3, and all the way up. Now, integers are the numbers that you learned in middle school. So they are your positive and negative whole numbers. So for instance, negative 2, negative 1, 0, 1, 2, 3, and so on. Now this is where it gets a little more tricky and we have to be very careful. We have what we call rational and irrational numbers. Now a rational number is a number that terminates or repeats. Now terminates means that it ends. So the number ends or it repeats. So it can be a decimal or it could be an integer. So negative 2, we could have 5. We could have negative 1.5, 6.25. Those would be rational. We could have 1/3. Now, if I do that in the calculator, let's double check. 1 divided by 3. So that's 0.33333333. Now, it doesn't end. It keeps going on forever, but it is repeating, which means it's a rational number. How about radical 9? Well, let's take a look in the calculator. The square root of 9 is positive 3, which means it's a rational number because it terminates, it ends. All right, let's take a look then at irrational number. An irrational number is a number that does not terminate or repeat. So it never ends, never repeats. So that's kind of a phrase that we can remember. It never ends and never repeats. Now, the most famous irrational number that a lot of you are going to remember is the pi. So pi, okay, is a decimal that goes on forever and ever. So here we go. It's 3.141592654, and then it keeps going forever. Another example of an irrational number would be radical 2. So if I do the square root of 2 in my calculator, I can see that it's a decimal, but now it goes all the way across my screen, and it would keep going if my screen would allow it. So this would be an irrational number because it never ends. I could have a negative radical 7. Now the negative has to be on the outside of the radical, so negative radical 7. Okay, again, it goes all the way across my screen. It never ends, and it never repeats. Okay, so now that we have our number systems, we're going to go ahead and use them. So here are our examples. Number 1, a function is used to predict the number of household online devices in terms of the number of people in the household. Which set of numbers could be used, which would be most appropriate to use? Well, we're talking about the number of people. So if we're talking about people, are we going to want negatives? Are we going to want positives? Are we going to want decimals? So you need to think about all those. So number of people, we want these to be positive, and we want them to be whole numbers because you can't have part of a person in your house. So integers are negatives, whole numbers, that could work. Irrational, nope, those never and never repeat. Those would be decimals. And rational numbers, well, those can also be decimals. That wouldn't work. So the only option here would be whole numbers. All right, let's take a look then at number 2. Is the sum of two rational numbers rational or irrational? Explain. So is the sum, remember sum means we're going to add, of two rational numbers. So rational numbers are numbers that end or repeat. So I'm just going to pick two rational numbers. So let's go ahead. I'm going to pick 6.5 plus negative 2. All right, now if I were to add those in the calculator, 6.5 plus negative 2, I'm going to get 4.5. So let's think, I just added two rationals. Was my answer rational? Yes. So I'm going to write rational because the sum terminated. Okay, so let's try another one. Number 3, is the sum of a rational and an irrational number rational or irrational? Explain. So again, sum means we're going to add, so I'm going to pick a rational number. Let's go ahead and pick negative 3.1. And an irrational, so let's go ahead and pick pi. Now it said sum, so we're going to have to add. So I'm going to go ahead, I'm going to add these in the calculator. So negative, just a reminder, the negative button is this button way down at the bottom of your screen. So negative 3.1 plus my pi button. Now pi is in blue there, so I have to hit the second and then hit that button, and now I'm going to get a pi on my screen. And then I'm going to hit enter. Okay, and I'm going to get 0.0415926. All right, so let's take a look. Is this number rational or irrational? And why? So at this point, the computer's going to stop again. You're going to have to write the word rational or irrational, okay, and mark your answer. All right, I'm hoping most of you picked irrational, and it's irrational. Now we have to explain because the sum never ended and never repeated. All right, ladies and gentlemen, you've just finished your first video lesson where we've accomplished our 2 goals, orders of operation and number systems. All right, very nice job today. I'll see you all in class tomorrow.